Even though there's nobody in the room, I'm going to go ahead and start the lecture. When we're talking about hearing, we're talking about the ear, of course. The external portion of the outer ear is the pinna. The pinna is, of course, the part you can see, and then it's the ear canal. The ear canal runs all the way to the tympanic membrane. It's primarily anything you can stick a Q-tip in. You can tell when you hit the tympanic membrane because it's very sensitive to touch. So people that burst their eardrums, their eardrum being the tympanic membrane, people that burst their tympanic membrane, they find it very painful, extremely painful. The middle ear is fluid filled, and because it's fluid filled, if it gets an infection and pus builds up, then we can see that the tympanic membrane is inflamed. Actually, if a good doctor can go in there with a needle and they can puncture that and they can drain the ear canal. They can drain the tympanic membrane, and they can find out what type of bacteria is causing the problem. You have to be very careful, though. It has to be a clean break, otherwise you'll lose your hearing, and you certainly don't want that. People with chronic middle ear infection, they will put tubes in here to drain off the excess fluid, so it doesn't cause an earache. The middle ear is a fluid-filled chamber. It has 3 bones in it. The bones are referred to as ossicles. Ossicles means little bones. It also has a eustachian tube. This is the eustachian tube here. It equalizes the pressure in the ear canal. The only time that you're really aware of the eustachian tube being functional is when you go up a mountain or come down a mountain. The eustachian tube, you need to equalize the pressure in there, and of course, if you're in an airplane, you come down. Your ears will pop, and it's the eustachian tube that is actually popping. It's trying to equalize the pressure. There's a trick to equalizing the pressure that they teach people who go up and down in airplanes all the time. One of the things you can do is you can close off both nostrils. Yay! You can close off both nostrils and blow into your ear canal, and it will force both of your ears to pop. It'll equalize the pressure. So that's a trick that they teach flying personnel is to equalize the pressure by blowing into the ear canal. Normally what happens is you have unequal pressure on both sides. You've got unequal pressure in your eustachian tube and in your middle ear. That's why your ears stop up. So what you have to do is equalize the pressure. And all you need to do is stop up both nostrils and then blow into your ear canal. And that works. Don't try to do it don't do it too much, or you'll give yourself an earache. The tympanic membrane touches the malleus, the hammer. Malleus is Latin for hammer, which vibrates the incus. Incus is Latin for anvil, which in turn vibrates the stapes, and of course that is Latin for stirrup. These are the bones of the ossicles. The reason they named them those names is because one looks like a hammer, one looks like an anvil, and then the other one looks like a stirrup. The ossicles are controlled by the tensor tympani attached to the malleus and the eardrum, and the stapedius attached to the stapes. So they're controlled by muscles, and we need these muscles. These muscles are extremely important because that allows us it allows the sound. If there's too much sound, these muscles will relax the bones and pull them apart so that you don't so that you don't lose your hearing, so that you don't get too much noise into your inner ear. The muscles of the middle ear contract and prevent ossicles from being too sensitive to sound, and of course that's a really serious problem. Stapes of the middle ear vibrates against the oval window of the inner ear. The inner ear will convert the mechanical energy of the sound wave into an electrical impulse that will read as sound in the brain. And of course that's what we're looking for. We're trying to determine what's going on outside. The auditory portion of the inner ear is called the cochlea. Cochlea is Greek for snail, and as you can see, it actually looks like a snail, and that's hence the name. So we've got all these structures in the ear that look like things: hammer, anvil, and stirrup, and then we have the snail. The cochlea is embedded deep in the temporal bone and is about the size of a pea. It's not very big. Unrolled, the cochlea is about 1.5 inches long, about that long. It's not very long. About the size of a pea. The oval window opens at the base of the cochlea. The length of the cochlea contains 3 non-compressible fluid-filled parallel channels: the tympanic canal, the vestibular canal, and the middle canal. And all of these, the fluid, of course, will collect the vibrations, and it will be judged as some type of sound. The structure that is actually the hearing portion of the ear is in the middle canal. So it's protected by these other 2 canals, the vestibular canal and the tympanic canal. And the reason that they are there is to collect vibrations, but it's also to protect the middle canal. You don't want to lose your hearing. What?
Oh, the one that lose your hearing. My father's been on the railroad for like close to 35 years.
Sure.
No hearing. I guess he's the age of our hearing aids. The train going by, the machine all around.
Sure. He's lost his hearing. All that damage done to all of his hearing. And when you're around a loud noise on a continual basis, pretty soon you don't hear it anymore. But actually it's destroying your hearing the whole time. So those individuals that are riding around in these cars with the really huge sound systems, they're destroying your hearing. They won't be able to hear anything. People that ride motorcycles, they're destroying their hearing. Their ears are trying to protect themselves. They are trying to protect themselves, and of course all that loud noise, that continuous loud noise, just all it does is destroy the hair cells. And we're going to talk about the hair cells in just a second. Those of us who have hearing losses, like your dad, or me, mine's not very bad because I wasn't around that many loud noises, but it was around constant noises. Constant noise will cause a hearing loss at a certain frequency. And by golly, I'm sorry to hear about your dad having such a serious hearing loss, but I guess if you're, when you're on a train, and of course you've been on a train, you don't even, in the beginning it seems kind of loud, and then after you've been on the train for 20 or 30 minutes, you can't even hear it.
Yeah, it's okay because now I can yell at him.
So you have to yell at him all the time. You can't talk to your dad. You have to yell at him. The basilar membrane separates the tympanic canal and the inner canal, the middle canal. This membrane vibrates in response to sound. It's right here. Within the middle canal and on top of the basilar membrane is the organ of corti, and that is the part that you hear with. The organ of corti contains the sensory cells of the ear. There are 4 rows of sensory cells, 1 row of 3,500 flask-shaped inner hair cells, and 3 rows of cylinder-shaped outer hair cells, 4,000 cells each. It's a lot of hair cells, but we need every damn single one of them because we're going to lose, eventually we're going to lose our hearing, just like your dad has. Too much stimulation, of course, will destroy the hair cells. Each hair cell has 50 to 200 stiff hairs called stereocilia or cilia. The cilia of the outer hair Cells extend into the indentations of the tectorial membrane that covers the organ of corti. Auditory nerve fibers can contact the base of the inner hair cells. Okay, so these are really delicate instruments. Babies, this is one of the reasons why babies are so sensitive to sound. They can hear everything. None of this has been damaged yet. Hopefully none of this has been damaged yet. So that's why babies are so sensitive to sound. They will wake up when you can't, when a sound is made and you don't even detect that sound. But the babies do, of course, because they have perfect hearing. They can hear everything. 90 to 95% of the afferent neurons are connected to the inner hair cells. Each inner hair cell is associated with 16 to 20 auditory nerve fibers. The afferent nerve fibers run to the cochlear nucleus of the brainstem. The outer hair cell is associated with modulating acoustic stimulation by strengthening and shortening to receive different frequencies. And of course, as you can see, we're talking about the different shapes, the two different shapes of the hair cells, and as you can see, they do look different. As the stapes moves, it causes movement in the fluid of the vestibular canal. Different frequencies of sound cause vibrations that stimulate different areas of the basilar membrane. Higher frequencies down near the window, lower frequencies farther away. And this is one of the reasons why a higher frequency sound, you can do more damage with higher frequency sound. So you lose your hearing at higher frequencies more readily than lower frequencies. This is really kind of weird because an individual will lose their ability to hear high frequency sounds. I've lost my ability to hear select high frequency sounds. But the reason is because those hair cells are closer to the source of the sound. So I've lost that frequency. This happens to individuals that work in factories, where there's a constant noise and there's a constant hum. Your dad with the constant rattle of the train. Of course, there's a sound of metal on metal, a screeching sound of metal on metal, and he's lost his ability to hear that. Now the interesting thing is, potentially you can talk to your dad and he can hear you fine as long as you speak in a deep voice. Okay. Of course, the more angry you get, the higher pitched your voice gets, and then all of a sudden he can't hear you. This is one of the reasons why men lose the ability to hear their wives, because their wives speak at a higher register. So as long as you speak in a deep voice, then you're probably okay. There was one of the first episodes of Big Bang Theory. Sheldon and Leonard break into Penny's apartment to clean it, and as long as they speak in a deep voice, Penny doesn't wake up. But when they speak in a higher register, she starts stirring.
Yeah, I noticed that some of the engineers that we work with, they had that higher, that voice that you made.
Yeah.
They haven't. It sounds like they were, even after the job site, you see them somewhere like in other band activities or community activities. It seems like they're yelling, but that voice is way up there, booming. And
Exactly.
some of the kids, they get scared, or they're wondering what's he's preaching, or maybe just getting mad at someone.
But the reality is they have to speak in a loud voice if they're going to speak at that high register. But as long as they speak at a lower register, you can hear just about everything that they say. It's really kind of interesting. They have done research with fetuses, babies in the womb, and what they've discovered is that the babies can't hear higher pitched sounds because it doesn't penetrate the skin and the amniotic fluid, but lower pitched voices. So the babies are actually listening to their fathers because their fathers have deeper voices than their mothers do. So they really can't hear their mothers nearly as well as they can hear their fathers.
I see. When my son was in the womb, I have a sister that has a really high pitched voice, that makes you like cringe.
Yeah.
And then we had a coworker that was a hostess. Her voice was like that. every time they would talk, my mom or my wife would feel the fetus moving around. And after he was born, we took him to the same place, the hostess, and or when my sister visits, you know, they speak and I think he notices it.
Yeah, yeah, like he's afraid. Exactly. As funny as that is. So if you want to, so a lot of babies find deeper voices soothing. When I was working in neonatal intensive care, of course, there's just a ton of sounds. They're all in incubators, so they're all in a closed environment. But they wouldn't respond to the nurses. There was one deep voice nurse that they would respond to. But I would come in and they'd all get quiet, as if they were all listening to what I had to say. And of course, I'm talking practically the entire time I'm there. My voice is is fairly deep, but it seemed to quiet the babies down when I was in there. They had one baby that was fragile. Oh, this baby was so fragile. And I would go in there to draw blood gases on him. And if one of the female lab techs went in to draw the baby's blood, they couldn't get a good specimen from him. But if I went in and I talked to the baby, or I was just talking to the nurses, I'd get a good specimen from him. And at one point, of course, the baby was doomed. The baby was doomed.
Oh, no.
Yeah, but of course they kept him alive as long as they possibly could. But one night I was working and they called me in and they said, just talk to the baby. His heart rate had skyrocketed, and they couldn't. One of the nurses had noticed that the baby became normal when I was in there.
Yeah.
So they called me in and I started talking to the baby. I must have talked to the baby for 15 minutes, and he was in crisis. And he came out of the crisis because I was there. Of course, I couldn't stay with the baby forever. Anyway, what happened was I got another job and I left the hospital and the baby died like the next day. It was really, it's tragic, but there's not a whole hell of a lot you can do about it. I can't sacrifice myself for the baby, I guess. I don't know. I didn't sacrifice myself for the baby. Anyway, the baby died. Or that other nurse, and that other nurse had a really deep voice.
Yeah.
But she especially had a deep voice when she was flirting with somebody. So, women get deeper voices when they flirt. And she was kind of interesting. She used to flirt with me. She was taller than I was. She was like, kind of tall, but she'd flirt with me. It was kind of fun. Anyway, her voice got deep, and the baby got better. The tips, and of course, you couldn't. The other nurses, you couldn't convince them of that.
Mm-hmm.
Because it was almost insulting to them that the baby wasn't responding to them. Oh, I've got, I'm a woman and I have mother love. Well, yeah, maybe, but you've also got a high-pitched voice that breaks glass, Anyway, yeah, the other nurses got upset. And actually they didn't really fire her. They let her go.
Mm-hmm.
Not because she was flirting, but because the babies responded to her differently. And the other nurses got jealous. This is in Oklahoma. Edmond, just north of Oklahoma City. The tips of the cilia of each hair are connected with narrow threads called tip links. And here are the tip links. You can see the tip links right here and right here. As the cilia is moved from sound migrations, the tip link starts a process of depolarization. Each tip link is connected to a potassium channel that, when open, depolarizes the cell. As the depolarization reaches the base of the cell, calcium channels are open and the synaptic vesicles release a neurotransmitter, acetylcholine. So if it wasn't for acetylcholine, we wouldn't be able to hear. If it wasn't for acetylcholine, we wouldn't be able to move. If it wasn't for acetylcholine, we wouldn't remember anything, because it's acetylcholine that provides that aspect to our memory. As the depolarization reaches the base of the cell, okay, we've already talked about that. Because of the delicate mechanism, very low sounds can be detected, and of course, you and I have both been in pressure chambers, so we understand these things. We understand how much hearing, how good our hearing is. The strange thing is that your ear actually makes its own noise. As that is, the cochlea makes noises in response to noises that it hears, and this is known as evoked autoacoustic emissions. In some people, it produces continuous sounds known as spontaneous autoacoustic emissions, SOAEs. 2/3 of women and 1/2 of men produce SOAEs. Now, strangely enough, these people hear better than people who don't put off SOAEs. So you have to ask yourself, why in the world do women need such delicate hearing? And of course, the answer is why. Why do women need such good hearing?
To be heard, I would say like all animals and stuff like they need for the infants.
Exactly. Exactly. Okay, so as humans evolved, the women who took care of their babies the best, the ones that reacted to very subtle sounds, were the ones whose babies survived. So women are more likely to be able to hear their babies when the babies cry. Now the interesting thing is, I don't know how interesting it is, but I have this. I'm one of the 1/2 of men who have SOAE, so I have really good hearing, and I've always had good hearing. However, my first wife, and I think I've told you this story, she breastfed my son, but she would never get up to go get him at night. It wouldn't wake her up, but it would wake me up. So I would go get the kid and I'd attach him to my wife's breast, which sounds horrible, but the reality is when he was hungry, there wasn't much else I could do. But she never woke up. And she left when he was 9 months old. So potentially, she didn't have very good, she didn't have SOAEs. She didn't wake up at night. I always woke up with the kids at night, despite the fact that she wasn't working. I was working. I had to get up at 4 o'clock in the morning. So if it's 2 o'clock, instead of her getting up with the kids, I'd get up with the kids. And then, of course, I wasn't getting enough sleep. It was kind of an ugly situation. And eventually she took off because, I don't know, she didn't like taking care of kids, I guess. Anyway, SOAEs, and I have this sensitivity to hearing, to sounds, I'm sorry. Each afferent nerve cell feeds into the auditory nerve, which enters the brain in the pons in an area known as the superior olivary nucleus. This in turn delivers the message to the inferior colliculus and the medial geniculate nucleus before it enters the auditory cortex. And you can see the process as it's moving in. Hearing is one of your more sensitive senses. It's the quickest of your senses. We respond very rapidly to sounds. And it's because it doesn't have very far to travel.
Now, usually, I play guitar, and the one interesting I noticed, I like one of the things I noticed I like about guitar is tuning.
Okay.
And when you tune, you hit the first string, and there's that vibration. You can tell the difference of it. What you want to do is get the harmonics really in tune with it, and you go to the next string, and you hit all the harmonics. And there's a little vibration you can, not only can you hear it, but it feels like you can feel it. That's the part of it. When I was looking at this, the PowerPoint on it, and I saw how it like goes right into the canal, and when your brain picks it up, and you tune it.
Yes. Now the funny thing about tuning a guitar or tuning a piano, for example, is the funny thing is the first note is always the purest note. So what some people will do, they'll tune one string, and then they'll go and do something else, and then they'll come back and tune the second string, and they'll go and do something else, you know, and they'll tune them. They take time in between, because if they tune one and then tune the other, the one, they wouldn't be as sensitive to the second string as they would to the first string. Okay. I don't know if you do it that way, or if anybody's ever told you that.
It's the root note, the first note I usually use the E, and then go down
Mhm.
until the last string is E. But some people tune different guitars, so it's usually D, or they drop down to a B.
Or they'll tune the lowest sound first, and then they'll move up.
I've never done that.
Okay, try it and see if it works. Like I said, a lot of people, they have to leave and then come back and tune the second string. We're talking about a 6-string guitar, right?
Yeah, there's different tunings. There's 12 strings, and the bass is kind of this is normal, but then there's like 5-string basses.
Oh, okay.
And then on that there's acoustics too. Acoustics are like standing bass. Yeah, you can feel the vibration next to you instead of the artificial electric.
Well, you need to be really careful. The reason that you hear your voice differently than everybody else hears your voice is because it's vibrating through your head. So if you actually touch the instrument to your head, then you'll get a different tone than if it was held away from your body. I know, it's kind of weird.
I have the acoustics on the walls,
Mhm.
so when you're talking in the room, you can your voice bounces off and it
Comes back to your ear. There are 3 forms of deafness: conduction deafness, sensory neural deafness, and central deafness. Conduction deafness is a disorder of the outer or the middle ear which prevents vibration from reaching the cochlea. Conduction deafness is relatively easy to fix. We can just use a hearing aid.
Mm-hmm.
Sensory neural deafness is a disorder of the cochlea or the nerve fibers that conduct information to the brain. This is not as easy to fix because what we have to use is a hearing aid that is implanted into your skull or under your scalp. Central deafness is a disorder of the brain's auditory regions, and of course, if that's the case, then we can't fix that. Sensory neural deafness can be caused by many factors. There are hundreds of hereditary diseases that can cause destruction to the cochlea or the cochlear neurons. Drug-induced deafness can also affect the cochlea and its neurons. Once upon a time, we used to give people streptomycin and gentamicin. These are both sulfa drugs. These are both sulfa drugs, streptomycin and gentamicin. Strangely enough, gentamicin is yellow. It's really bright yellow. It damages the hair in the cochlea. Those of us who take aspirin, and people take aspirin to keep from getting heart attacks, the aspirin coupled with loud noises reduces cochlear sensitivity and it causes tinnitus. Tinnitus is, I know it looks like tinnitus, but it's not tinnitus, it's tinnitus. It's a ringing, constant ringing in the ears. I developed tinnitus right at the end of my service. It wasn't too bad when I got out of the service. Of course, they give you a physical before you leave, and then if you have any damage done, then they'll give you, you will get disability. But unfortunately, my tinnitus wasn't bad enough at the time to get any disability, and now it's a lot worse. But it has to do with the fact that I have to take an aspirin every day, and I've got this, I've got this constant ringing in my ears. Fairly loud too. It doesn't interfere with my hearing. It's just there all the time. Some people it really disturbs them. It doesn't seem to disturb me very much, since I know what it is. The most frequent cause of sensory neural deafness is loud noises or continuous noises at the same pitch. Initially, outer hair cells are more sensitive to loud or intense noises, but eventually the entire organ of corti can be destroyed, in which case, of course, you can't hear anymore. Loud, sharp noises seem to be the most destructive, such as guns. When you shoot a gun, motorcycle engines are extremely loud. That's to borrow money. And intense music, of course. So those people that, the cool people that go to concerts all the time, all they're doing is blowing their ears out, and they will lose their hearing, as sad as that is. While the cochlea allows people to hear, the rest of the apparatus attached to the cochlea allows us to keep our balance. There are three parts to the vestibular system: the semicircular canals, the saccule, and the utricle. This has to do with balance. This is your vestibular system. Receptors of the vestibular system are hair cells similar to the auditory system that are located throughout the semicircular canals. And these are the semicircular canals, these loops, and they go at right angles to one another. At the base of each of the three semicircular canals is a structure called an ampulla. And the ampulla, as you can see, it's an extended area at the bottom of each vestibular canal. In the ampulla, the cilia of the hair cells are embedded in a gelatinous mass. Each hair is very delicate and quite precise in the kind of mechanical force that it is sensitive to. The first time you fly in a jet airplane, probably you'll throw up because of the quick movement. You're not used to that type of movement. You're pulling G's, and your semicircular canals don't function very well. I've known people that who were in pilot training who had to leave pilot training because they couldn't handle the sudden movements of jets. They couldn't handle the G-force, which is really kind of unfortunate. They had geared their lives to fly airplanes or fly jet airplanes or be a fighter pilot or whatever, and here they couldn't do it. They just couldn't do it because their equipment didn't work quite right, and the more they tried it, the worse it got. The three semicircular canals are at right angles to each other and detect angular acceleration in any direction. If it's an individual that reacts to those movements, then probably if they get on a roller coaster, they'll throw up every time. Especially if it moves. If it's a constant movement and the movement isn't jerky, they'll probably be okay. But it's the ones that have those severe right angles, or the ones that you suddenly shoot down and then all of a sudden you flip over. Those types of movements will cause the individual to throw up. The receptors in the saccule and the utricle respond to static position of the head. Static position of the head. These are known as otoliths. These little bones, or tiny little bones. Sometimes these can get out of place, in which case you get vertigo. I had vertigo, when was it? 2 summers ago. I had vertigo 2 summers ago. And I thought, actually it started when I was here. Of course, there's the difference between being here and being in Iowa is like is 7,300 feet. It's 7,500 feet here, and this is very, very different from where I live in Iowa, where it's only 200 feet above sea level. But this is 7,500 feet. So I assumed it was inner ear infection, that I was having inner ear infections. But what was going on, because I'm at this elevation, and the air pressure is different up here than it is in Iowa, sometimes my otoliths would get displaced. And I would get vertigo. You know, I would stand up and I couldn't tell whether I was standing or I was about to fall down. It was really kind of weird. It usually happened in the dark at night. But sometimes it happened during the day. So what I would do, I would lay down, and eventually what happened was it would go away as long as I was laying down. Then I'd get up, and as long as I didn't get up fast, I was okay. So I went to see the doctor, and I said, you know, this is debilitating. Sometimes I'm really dizzy. And he said, you've got vertigo, and your problem is these otoliths are getting in the wrong position. So in order to fix it, what you have to do is you have to hyperextend your neck to whichever side is the problem. Hyperextend your neck and lay flat. And that eventually that will correct, they will settle back into the right position. And that's exactly what happened. I haven't had vertigo since he told me about that. So one of the guys here was in an explosion, and he's got vertigo pretty bad. And I told him, well, maybe you ought to try this and see if it works.
Yeah.
I mean, if it works for me, because I travel from 7,500 feet to 200 feet, then maybe it'll work for you. And it did. It actually has cured his vertigo. But what you need to do is let those little rocks settle. You know, let the sand settle in your ears, and you'll be okay. Okay.
Nice traveling tip.
I'm sorry?
A nice traveling tip.
Yeah. Well, you know, most people don't get vertigo when they travel. This is if you're not in an extreme situation, then these things aren't going to happen to you. You know, if you stay here all your life, you're not going to ever have to worry about it. But I travel back and forth all the time. I'm old. That's another problem. And since I'm old, this gelatinous membrane is drying out. And that can be a potential problem. The other guy was in lots of explosions. I'm pointing to the chair he sits in. But it seems to help him. So whenever he's got vertigo, he just hyperextends his neck and lays down on his side. And that settles his otoliths. At the base of the hair cells in these receptors are nerve fibers connected in a similar manner to that of the auditory hair cell. And these are, otoliths are really tiny little things. It's like grains of sand, except smaller. They're crystalline, and of course they're in a gelatinous membrane, which allows them to stay in the same position almost continually. But you know, you're in an explosion, and that's the kind of thing that happens. If you fly in airplanes, you know, this is very common. If you go up 30,000 feet. This is a really serious problem for the guys that used to fly the SR-71. The SR-71 is what do they call it? It's a supersonic jet, but it flew at the edge of it flew almost up into space. It didn't escape. It flew at just below outer space. And because of that, these guys had really serious problems with vertigo in the beginning. For that reason, they would have SR-71 pilots. They trained them to fly the SR-71. They would be in service for a couple months, and then they'd have to retire because they were having really serious vertigo problems until they figured out how to fix it. So the doctor was telling me a technique that the Air Force actually did. Put together. They're the ones that came up with it because they had a pilot that didn't want to not fly the SR-71, and so he experimented with different techniques. Yoga. He started out with yoga, and he realized that it was curing his vertigo when he was in a certain yoga position, and then he just kind of interpolated that this position, it had to do with the position of his head, and it all gets better from that. The reality is you have to hyperextend your neck, and when you hyperextend your neck, it changes the muscle tension in your ears. You know, it had something to do with that. Anyway, and he was a friend of mine. This guy flew B-52s in Vietnam. He flew out of Guam, and he served 2 tours and he never saw anything in Vietnam because Vietnam's real misty. There's a lot of mist, so he never actually saw the ground. You know, he's flying up at 30,000 feet and he never sees the ground. The only thing he saw of the ground was when they fired missiles at him. Then he would see the vapor trails and whatnot. Most of the nerve cells of the vestibular receptors enter the lower level of the brainstem and synapse in a group of nuclei called the vestibular nuclei. While some of the nerve cells tie directly into the cerebellum, those that pass through the vestibular nuclei tie into various motor and muscular control areas of the brain, and that allows you to change your position. The better all of these connectors, the less likely you are to get vertigo. The better that you're able to ride a bull, the better that you're able to fly a plane, the better that you're able to ride on a roller coaster. Motion sickness is caused by low frequency movements due to acceleration. Motion sickness is usually worse for the passenger in a car than the driver. The driver knows exactly when they're going to turn because they're the ones that are doing it. And for that reason, it's usually worse for the passenger than the driver. And it's also worse for the person in the back seat because there's more movement. The farther back you get in the vehicle, the more movement there is. That's one of the reasons why if you're right in the back seat of a bus, you're more likely to get motion sickness than if you sit right behind the driver. Motion sickness can also be induced when the fluid in one ear is warmer than another, and this is the case when the individual has inner ear infection. I've had about 4 inner ear infections. They're not a whole lot of fun. You feel like you're drunk. You feel like the world is spinning around, and the reason is because one side of your head is warmer than the other side of your head, and for that reason, of course, your vestibular system is all out of whack. So the funny thing is, your eyes will try to capture the movement. You know, as far as your ears, your vestibular system is concerned, you're flipping from side to side. And so your eyes are trying to actually catch that movement, and there is no movement. So here your eyes are just flipping from side to side. It's the oddest thing you've ever seen. The only way you can stop it is by closing your eyes, because your eyes are just flipping back and forth. And normally you're not used to that. It's extreme saccadic movement, saccadic eye movement. A human sense of taste is based on several survival needs. Since sugar is the energy source for all of our cells, it is important that we are able to detect sugar in our foods to ingest as much as possible. The closer we are to sugar, the better we are, or the better fed that we are. If we could just eat raw sugar, we would be able to maintain ourselves. And of course, this is what they're looking for when they think about space travel. They'll just give us some kind of paste that breaks down into sugar, probably a monosaccharide, a single molecule of sugar. The more pure, the better. So you could potentially you could live on honey because it's a monosaccharide. The more it has to break down, of course, the more you have to digest. The more you digest, the more waste product that you have. So they're looking into all of these things. If a food does not break down into sugar, then it's not food. It isn't food because it's not nutritious. Okay, so we can eat potatoes. It's a starch. It's a polysaccharide. It has several different sugars. The closer it is to a monosaccharide, the sweeter it is. So what table sugar that we eat, cane sugar, is disaccharide. So it's not nearly as sweet as honey. Honey is very, very sweet. If you've ever eaten clover, just chewed on clover. That's a monosaccharide too. It's really, really sweet. Anyway, it has to break down into sugar in order for us to utilize it. Salty and sour foods indicate to us important ion structures that help us maintain our homeostasis. We need salt and we need acid in our diets. So those are two flavors that we're looking for. The one substance that we aren't looking for is a bitter substance, and this tells us that it is toxic, that the substance is toxic. Taste receptors are located on small projections from the surface of the tongue called papillae. Each papillae holds one or more clusters of 50 to 150 cells. Most of these cells are taste buds. The more taste buds you have, the more tasting that you actually do. Some people are called super tasters. They have so many taste buds on their tongue that they can taste, they can pick flavors out of different foods. Most chefs are super tasters.
Most chefs smoke too.
And the reason they may smoke is because they're trying to tamp down their taste buds, because they're really sensitive to flavors. They're hypersensitive to flavor. They put some odd flavors together, though. I mean, my son's a chef. He just drives me nuts. I can't stand. I can't drink alcohol because it hurts my tongue. It burns my tongue. So I've never really desired alcohol. I'm a super taster too, which drives my wife crazy because she's not. So she'll eat like anything and think it tastes good because she doesn't really taste things. But I'll eat it and I'll say, no, it's got too much garlic in it. She'll go, they didn't even taste the garlic, that kind of thing. The taste buds are arranged in a depression that will catch fluids. If something will not break down, if the chemical won't break down in water, then you can't taste it, because that's what tasting is all about. The chemical tastant enters the taste bud through the taste pore. Taste cells extend cilia into the taste pore to detect different chemicals, and of course that's what we're looking for. There are no pure tastes. Well, there is one, and we use it to experiment on people. Some of the sensory cells in the taste buds are pain and touch sensors that detect hot foods such as jalapenos or habaneros. And I told you my story about habaneros, or whatever they were. There was some something god awful jalapeno from Mexico. Literally blistered my tongue. I couldn't taste for like a week. I couldn't taste anything. I mean, it was horrible. So I didn't eat. I mean, if you can't taste something, everything tastes like cardboard. Taste buds only last for 10 to 14 days before they are replaced. There are three different structures of taste buds: fungiform, circumvallate, and foliate. Fungiform means mushroom. Circumvallate means rampart around. So it has is a structure. It's like a fort. And you have to get it into the rampart. And foliate, this is what a foliate looks like. It's a mini layered taste bud. As curious as that is. The salty taste comes from the sodium being transported across the membrane of the taste cells. The entry of sodium ions depolarizes the taste cells and activates the afferent neurons. So that's why you taste salty. I like salty. I also like sour. Sour taste is usually an acidic compound that releases a hydrogen ion. This hydrogen ion blocks the potassium channels. The buildup of potassium depolarizes the cells and causes a stimulation of an afferent neuron, indicating an acidic flavor. So then we eat those acidic foods, like you were saying yesterday. Rhubarb is very acidic. Lemons are very acidic.
Pickles.
Pickles. Yeah. And if you eat too many of them, it will not damage your tongue, but it will make your tongue will get sore. Ten 20, okay. I have to remember what time I quit. Sweet tastes are slow, are very, very slow. Because they're metabotropic. They involve G proteins and second messengers. It is not, we don't really understand why sweet is sweet, but it's a very complex mechanism. Bitter is also a very complex mechanism. It may actually be different for each toxin, different poisons. If you've ever tasted caffeine, caffeine is very bitter. Nicotine is poisonous. And it's bitter. All of these things are poisons. They're alkaloids, and alkaloids tend to be, in heavy doses, they tend to be toxic. Studies have been done looking at the bitter chemical phenylthiocarbamide, and they have discovered that about 1 in 4 individuals cannot taste the substance. I was at a seminar in Vancouver, and we had a lady that gave everybody phenylthiocarbamide, just to see how many of us in the audience could taste it. And there were like 3 people in the audience. There were probably 1,000 people there, and there were 3 people that couldn't taste it. These are all psychologists. And I found that just fascinating. That psychologists, 1/4 of the population can't taste this stuff, yet almost all the psychologists could taste this stuff. Now the interesting thing about the 3 people that couldn't taste it, they were more extroverted than everybody else. They seemed less sensitive to things than everybody else did. I mean, this was taste. This is a chemical structure in your mouth. No, but yet almost everybody in that room was sensitive to this stuff. It shouldn't have been that way. I mean, there should have been 250 people in that room that couldn't taste. They couldn't taste this stuff, but only 3 people couldn't taste it. So being a psychologist and studying psychology and worrying about people and trying to figure out how the brain works and being introverted, all of this stuff may go together. So hypersensitive people are more sensitive to other people's emotions, potentially. And it goes all the way down to your senses. It takes in all of your senses. The 3 people that couldn't taste it, like I said, were more extroverted. They were the loud ones in the room. They were the ones that were talking really loud, and looking over everybody's heads. It's just really kind of interesting that here we're talking about taste, but what we're really talking about is sensitivity to other people, or sensitivity to anything. And these people were just not very sensitive to anything else. Now the funny thing about this stuff was that she put like 5 micrograms. I mean, it was a tiny, tiny amount on these pieces of paper. And it took me probably 30 or 40 minutes to get rid of that taste. It was crazy. I had to drink a whole bottle of a 24-ounce bottle of Coke in order to get rid of the flavor. And it was still there. It was the oddest thing in the world. Now one of the other funny, well, I won't go into the other funny thing, because one of my friends was one of the guys that couldn't taste it. And he was a minister.
Oh.
I know, that was weird. And you would think that a minister would be sensitive to people. But the reality is that if you're a minister and you're always talking to people that are complaining about things, I don't know. You don't want to talk to people about God, because you've got your beliefs and want to argue with people. You don't want people to argue that God doesn't exist and whatnot. So, and he was that kind of a minister. I mean, he wouldn't brook any conversation about God not existing. I mean, he was just a really funny guy.
I think. See, before I took the psychology program, I believe I was not really sensitive to a lot of areas.
Mm-hmm.
And after I took the program, I noticed all these little stuff. It does count to people's thinking,
Right.
emotions. You know, when you like even movies or even stuff that everyday stuff that I thought I would just pass by or not even pay attention to. It's actually it does make a difference, and I pick up how insensitive I was,
And how sensitive you
and how
become.
insensitive I become. Yeah.
Which is why we're teaching you these things. But those people didn't pick it up. And all of these individuals were heads of programs. They didn't really deal with students anymore. It was a teaching psychology seminar. But they didn't really deal with students anymore. I mean, they had gotten to the point, and of course, if you're not sensitive to people, then people aren't going to respond to you, so you don't want to do it anymore. So instead of, I mean, what are you going to do? Either change jobs or keep moving up the ladder, where you have less and less contact with the individuals. And that's what they had done. These were all heads of programs, all three of them. And of course, nobody quite noticed that, you know, except me. Nobody wanted to insult these people, but I noticed. I knew what was going on. It was kind of interesting. They have also determined that those who do not have the ability to taste this substance have fewer taste buds on their tongue, which makes them not a super taster. And my wife can't taste this stuff. So when she cooks, and she cooks for herself, a lot of her food tastes like cardboard. She loves frozen pizza. Frozen pizza tastes like cardboard to me. Not even the sauce tastes any good. But here she eats that stuff. So we, usually I do the cooking, because she doesn't ever she doesn't put enough salt in things. She eats food without salt. I mean, how can you eat broccoli without salt? I mean, who does that? So we have all these different taste buds. One of the taste buds that the Japanese claim we have is a fifth taste called umami. Umami in Japanese means good taste. Back in the old days, if you went to a Chinese restaurant 30 years ago, Chinese food tasted really, really good. And the reason it did is because it had monosodium glutamate in it. But there are a lot of people that are allergic to monosodium glutamate.
MSG.
MSG, yeah, it's MSG. Monosodium glutamate. So they don't put it in Chinese food anymore. And now Chinese food doesn't taste nearly as good. In order to make Chinese food taste good, you have to put a lot of soy sauce on it to give it a flavor, because it has no flavor. But in the old days, Chinese food was really, really tasty. Now you have to ask yourself, why are there so many people in the United States? I mean, they put monosodium glutamate in Japanese food in Japan, and they put it in Chinese food in China. You can go in other places and get monosodium glutamate, but not in the United States. So why in the world would people in the United States be so sensitive to monosodium glutamate? What's going on here? The answer is, are you ready? The Chinese grow up with monosodium glutamate. The Japanese grow up with monosodium glutamate. In the United States, we don't, unless it's somebody that eats a lot of Chinese food. Well, even if they do, they don't get monosodium glutamate anymore. So because this is a new flavor for us, this is a new chemical structure, and it is toxic. I mean, it has to be toxic, otherwise we wouldn't be able to taste it. We have individuals that are hypersensitive to it. So because there is a certain percentage of people in the United States that are allergic to monosodium glutamate, they've taken it out of Chinese food. Okay. as stupid as that sounds. You can't even get it in a Chinese restaurant anymore. They won't even, in the old days, right after they decided the monosodium glutamate was too toxic for Americans, there was still packages of monosodium glutamate in the at Chinese restaurants, and you could sprinkle it on top of your stuff, but you can't do that anymore. Researchers have discovered that monosodium glutamate stimulates the umami taste buds, the umami receptors. Umami tastes like, it's really hard to explain what it tastes like. It tastes like meat. Okay, it's a savory flavor. Yeah, it's good. It's a good flavor. I mean, it really has a really nice flavor. I think, anyway, but then again, I'm not sensitive to it. Umami receptors detect amino acids, which is abundant in protein in meats. Umami receptors seem to be shared with the taste buds that detect sweet, so they don't have their own taste buds. But then again, in Japan, they don't eat sweets. So the taste buds that taste sweet in the United States, where we eat a lot of sweets, actually taste umami in Japan. I don't know if how much Japanese food you've ever eaten, but a lot of it is kind of bitter to us, but then again, we're used to sweet foods. They don't have meats over there. What they eat is fish. Where was I? They were talking about muffin. The Vietnamese eat fish sauce. A study done by the National Geographic magazine showed that half the people that tried their test were able to detect all the odors present. So they were able to smell all the things that they had to smell. Half the people smelled everything. 1/3 of the people tested were not able to detect the sweat odor. 1/3 of the people in the world can't smell sweat. They don't smell body odor. 1/3 of the people. 29% were not able to detect the musk smell. And most of these people couldn't detect the musk smell either. What is the musk smell? The musk smell is the sexual smell. It's the sexual smell for elk. But it's also a smell that humans can detect. Well, 2/3 of humans can detect it. 70% of humans can detect the sex smell. So there's 29% of the people don't detect sexual odors. 1/3 of the people could not detect body odors. And that's one of the reasons why there is 1/6 of the population that never bathes. They can't smell themselves. 1/6 of the population never takes a bath. I had a sister-in-law that never took a bath. She never bathed. She might bathe once every 2 weeks. Her hair was greasy. She has since died, but she was one of the people that couldn't smell things. She couldn't smell sexual odors and she couldn't smell body odors. I don't know about the sexual odors part. I was not that intimate with her then. I discovered that. Strangely enough, women were slightly better than men at detecting odors. The ability to detect odors declines with age. Smokers tend to have a dull sense of smell. And that's one of the reasons why they don't eat as much as people who don't smoke. I find this fascinating because odors are really important to me.
Yeah.
I mean, here I have just discovered I've got PTSD, and the reason I have PTSD is because of odors. And of course, we've got some people, so we've got all these combat veterans, these people that have been around the same shit that I've been around, and I'm sensitive to it and they're not. Well, part of the answer might be here. Sure, I respond to it, but I have a really good sense of smell. I also have a really good sense of taste. So flavors are very important to me, and odors are very important to me. because they smell everything. Damn it.
Most people like the smell of rain,
Right.
so it kind of like calms them. Or to me, rain is like I think when I smell rain, it puts me back into like a clean slate. Everything's like
What are you really smelling?
wet dirt,
You're smelling
ozone.
always O2 and earth. That's what you're really smelling.
Like the wet dirt, the water.
Well, yeah, potentially you're smelling the wet dirt, but you're also, the air is fresher.
Yeah.
Why is it fresher? It's got more oxygen in it
Okay.
after it rains. Yeah. But what else are you smelling? Well, you get the, if you're walking along the street and it's a dry day, you're smelling dust. But if you're walking along the street and it's a rainy day, you're smelling the oil coming out of the asphalt. That's why right after it starts raining, the road is the most dangerous because you get that layer of oil on the road, so the road is a little slicker. So it really all depends on where you are. Sure, you're smelling mud. All of a sudden, you're smelling mud. Dry smells, sometimes you can't detect them, but wet smells you can detect. So let's say that something died in that, or somebody peed on that dirt. When it rains, there is a smell of urine and dead flesh coming out of the ground.
There was a place I worked for. She lived up towards east, I don't remember, but she was telling us that she grew up dirt poor, where her house was dirt. That's how she explained it. Is that later, because when she was small, the dirt tasted so good, that she would eat it. And then when now she's way, like she's a math teacher, and she did like a whole bunch of investments, and she would tell us about the stories about how she used to eat dirt, and now it's just like it reminds her of her childhood. Even just the taste of she probably secretly got dirt, tasted or something, but she used to do a lot of gardening, and that was.
So why would you eat dirt? What could possibly be in dirt that you would find?
I would say iron.
Necessary. Iron, exactly.
Yeah.
Yeah. So women, some women who are pregnant and aren't taking their pills have an iron deficiency, so they will crave dirt. Now let's pretend that we've got a lady let's think of our friend who lived in a house where it had a dirt floor. So the dirt floor, what's on that dirt floor? We're cooking every day.
Yeah.
And if we're cooking with grease, it gets into the air, settles on the ground, now there's fat. Now there's fat in the floor. It's one of the reasons why you ever go into a house that has a dirt floor, that it's dark. Well, the reason it's dark is because they've been cooking in there, and the grease has settled on the floor. So it's actually got a layer of fat, to some extent. I mean, it's not a lot.
Yeah.
Okay, so there is some nutrients in that dirt. Potentially, there's some nutrients in that dirt, and it's the fat that they've been cooking with. Bacon grease, lard, whatever they're cooking with. And so it's logical that she would crave dirt, and especially if she wasn't getting enough nutrients with her food. Hi.
Hi.
They're talking about eating dirt.
Eating dirt?
Makes you hungry, doesn't
I
it?
used to like the smell of wet dirt.
There you go. There you go. Ozone.
I had
Well-
a flat tire this morning.
I'm sorry.
And then I was like the 5th person in line to get it fixed.
Flat tires. I swear. We're talking about flavors. Odors are detected by a sheet of cells along the top of your nasal cavity called the olfactory epithelium. You can see how far it has to go in order for the odors to get there. Each receptor cell has a long, slender apical dendrite that extends to the outermost layer of the epithelium, and this is on the mucosal surface. So what we're detecting actually is chemicals. It's just like in your mouth. When you eat something, if it doesn't break down, if you can't break it down in water, then you can't taste it. As far as odors are concerned, this is one of the reasons why this room doesn't smell really strongly, because all of this stuff that we've got in this room. We've got the ink that has an odor to it. It's got oh my goodness gracious, it's got alcohol. It smells like alcohol. Well, so why do we smell a lot of things? Well, a lot of the problem is, first of all, the chemical has to get to us. And we're talking about molecules of chemicals, and that's all we can detect is molecules of chemicals. So if there's a lot of chemicals, then we're okay. If there's not very many chemicals, then we can't smell it at all. So anything that you can smell, you're actually smelling that chemical. When you smell a fart, you're actually smelling the methane, the methane gas that is coming out of that individual, and sulfur. It's usually the sulfur smell.
Is propane? That's like an artificial smell where it can.
Yeah, they put
smell.
sulfur in it so that you can detect it, because it's poison. It will kill you if you get around too much propane. So it's a real serious problem.
I know one time my husband left the stove, the propane on overnight, and we all woke up to it and it stayed.
Yeah. Yeah. It's serious. At the mucosal surface, numerous cilia emerge from the dendritic knob and extend along the mucosal surface. At the opposite end of each olfactory receptor cell, a tiny unmyelinated axon runs to the olfactory bulb. Olfactory neurons are constantly being replaced. The problem is, of course, that this is a very slow process. Smelling things is a relatively slow process. Hearing things is a relatively rapid process. It doesn't have that far to travel, but odors have a pretty far distance to travel. The slowest sense is probably your sense of taste. That's probably your slowest sense. Second slowest sense would be your sense of smell. The odorants enter the nasal cavity in the form of free-floating chemical molecules in the air during inhalation, so you have to be able to breathe it. And just like in your mouth, you can't taste something unless it breaks down in water. Well, unless you have enough moisture in your nose, then you can't smell anything either. So if your nose is continually dry, for one thing it'll start bleeding, but if your nose is continually dry, you can't smell things very well. So the people that can smell the best are the people that have a little bit of mucus in their nose. It has to be moist, or the chemical will not attach itself to the mucosal layer and you can't smell it. Okay, so if your nose is too dry, you can't smell anything. If it's too wet, of course, it's too blocked and odors don't get up there. It's one of the reasons why when you have a cold and your sinuses are plugged, that you can't smell anything. And because your sense of smell and your sense of taste go together, forming your palate, if one of those is missing, like when I had my taste buds burned off by those damn peppers, those damn Mexican peppers, I couldn't taste anything, and so I wasn't hungry because I couldn't taste, and nothing tasted good to me. Same way, it's the same way with when you have a cold. It's the most bizarre thing in the world. If you have a cold, you can eat things and you can taste them, but they taste different than they did before, and maybe they don't taste as good. I really like the flavor of Code Red, Mountain Dew. Red Mountain Dew, I love it. But when I have a cold, it tastes chemically, it tastes like a chemical to me. And I don't crave it nearly as much, which is really kind of odd. And there are other things that you can eat. You have to eat almost really strong foods in order to get any flavor whatsoever. So I eat a lot of chili when I have a cold, because it has a strong flavor to it. But you don't want to eat, you don't want to eat mashed potatoes and chicken and noodles or something, because all you'll taste is the only flavor you'll taste is the salt. So you don't really want to eat that kind of stuff. Sometimes if you eat something when you have a cold, it'll make you sick because the flavor is different. One of the things you don't want to do before you eat something is smell it while you're eating it, because the odor, you get too much of the odor, and it changes the flavor in your mouth. So don't do that. Don't sniff it while you're eating it. Otherwise, you won't eat it. The flavor will be different. What are we doing? Odorants first enter the mucosal layer, which binds the chemical to the protein, to a protein for transport to the olfactory epithelium. The viscosity of the mucous layer determines how rapidly an odorant reaches the cilia of the olfactory receptor. So in order to actually eat something, you need to not have a cold. It needs to be wet enough so that you might potentially need to blow your nose. And this is one of the reasons why when you eat, sometimes you get a little bit of extra mucus in your nose, and you need to blow your nose. Because while you're eating, you're also trying to detect the smell, and that causes your mucous membranes to weep. And so you get a little bit of, so you have to sniff up or whatever. And that's okay, because we're tasting things, and that's what we need to do. If we can't taste it, we don't want it. It doesn't taste nearly as good. How am I doing on time? Oh, it's time to stop. Oh, this gets to be really complicated anyway. We're going to talk about pheromones. We're going to talk about pheromones, which is kind of funny because what did I just say? 1/3 of the population can't smell body sweat, and 29% can't smell sexual odors. That's an awful lot of people. That's like 1/3 of people. Now the reality may be that American Indians, you guys had arranged marriages for an extended length of time, and it may be that you're one of those groups that you don't put off odors and you don't detect odors. It may be. When I was sweating up north, they used to complain about me sweating all the time because I'm a white guy. White guys have an odor about them, a different odor. And somebody just wrote me a discussion. And they said black people really have they really stink is what they said, but what they really meant to say is they have a strong odor. Well, yeah, they've got a strong odor. But you know, when I used to sweat with those guys up north, those buffalo hunters up north, they don't have an odor at all. It's nuts. They don't even sweat. It's irritating. You know, you're running a 3-mile race, you get done, and here I'm just dripping. I got sweat dripping all over me, and they get done, and they got nothing. They don't have. There's no sweat in their armpits. They've got nothing on their heads. You know, I've got to wear a bandana to keep it from leaking down into my arm. Anyway. So we're going to talk about pheromones, as fascinating as that is. But I may be just talking to myself, because you guys may not have them. Since there are so many people. Japanese don't have pheromones. Koreans mask their pheromones with garlic, because they put garlic in all their food.
Bruce, I know you're fascinated with religions, I thought I'll show you these. In Navajo texts.
Did you turn it off? Broadway?
I know. I'm sorry?
Did you turn it off?
Thank you.